to practice AP tests for friends.
Oh, and he does. I think you do like review sessions on the weekend, right? Before the AP test. Yeah.
There's no shortage of hours.
Yeah.
We'll hit 12 hours. We'll go past 12 hours. It's not. I'm not concerned about that part.
I'm gonna get. Watch me get the worst score.
Are we gonna review?
You have not seen my AP test.
As what we can.
I'm really instead of all of them, I'm good at convincing you.
Yeah, it'll be about half to a third, somewhere around.
I really am worried I'm gonna get like
That's
a
okay.
5 on CA and get a 3 on AP. Then I would have to retake AP next year.
What is Shuet mean?
If I got like a 5 and a 3, then yeah, maybe honestly.
What is Shuet?
Maybe like when you got a cap, if I should get let's retake the test. The AP test.
Yeah, not
No.
Okay, so we're starting with the radius of convergence, number 1. What do we have? We have n plus, God, this is such a pain. n plus 1, n plus 2, and yeah.
Is it still working weird?
Yeah, doesn't it look weird?
Yeah, it does.
Oh, I started pixelating.
Right? Pixelated. 4 to the n. X minus pi to the n. That pi could have been any number, but it's pi just to confuse people who aren't paying attention. Clearly, this is not a geometric series. We have n's that appear that in the places that are not exponents. So we're going to have to use a ratio test to find our radius of convergence. So ratio test. Oh no, it's happening already. Ratio test. Oh, you know what? I heard a tip about this. Like, what if I changed my pen sensitivity, whatever? Yeah, make it more sensitive?
That makes sense.
Your pen just freaks out on you.
Settings. Allegedly. Where is this? Do you think it's personalization or what? Ooh, no, never mind. Right hand. Ignore touch input when I'm using my pen. I don't even know what that means. What else? Pen shortcuts. Do you see? No, I don't see sensitivity, pressure. Do you?
What about touch?
Press and hold?
Where is it?
Press and hold?
I don't know.
Oh, she has it on the.
Of all the things I need in my life just in general, you making fun of me now.
Yeah.
Darn it.
I saw it because it said 38 and I was like, wait, that's not close.
Try touchpad.
Touchpad?
The whole thing.
Medium
No,
sensitivity.
and then I think she ripped.
I don't think that's it.
When you turned it on, now you're supposed to sign in.
I have
Yeah,
all
it's a little square.
Yeah. What is this called? This is called an oogie.
Mr. Carter, are
Yeah.
we gonna do the whole study guide?
Well, I'm gonna prioritize getting 1 through 9 done.
Oh yeah, that's what.
Yeah.
I really need 7 and 9.
Okay.
Because the endpoints I don't understand.
All right.
Just picking a random. Not a random. It's obviously not a random.
All right. I'm just gonna do this one time, and then if I don't see it, we'll just. All right. So where is it here? Right. That's where all my. Do I have settings for the pen? Disney's Magic Kingdoms. I don't remember installing that.
Maybe it can be one. You have 3D paint? That's cool.
Xbox.
Yeah.
My
Thank
favorite laptop.
you.
I know. I knew it. Let me live my life before I get rejected. Thank you very much.
Do you want to go there?
Like if I got
Ready?
rejected.
Ready? Here we go.
What? Yeah, I got it. I
so clearly I don't have it. I can't find it. All right, so let's just continue then. What do we have then? That's our ratio test. That's supposed to say ratio test. It doesn't. We're going to take a limit as n approaches infinity. We're just going to increment all those n's to n plus 1, n plus 2, n plus 3. That's 4 times 4 to the n. And then we also have x minus pi to the n multiplied by x minus pi. Yeah, I'm doing this kind of the old way. And multiplied by, what is that? 4 to the n, n plus 1, n plus 2, and that is 1 over x minus pi to the n. Set this whole thing to be less than 1 because I'm running out of room. Okay. Okay, it's pretty standard, right, the ratio test here. Cross out the terms that you can cancel. I can cancel out n plus 2 with this n plus 2 here. I can cancel this n plus 1 with this n plus 1 here. I can cancel this 4 to the n with that 4 to the n. Cancel that x plus pi with that x minus pi. And I think that's it, right? Okay, so that leaves me with the limit as x approaches infinity of, what's on the numerator? N plus 3. Denominator, n. X minus pi on the numerator, 4 on the denominator. This needs an absolute value. And we want that to be less than 1.
It should be n, right?
Where's that?
Limit n approaching infinity.
Yeah, that's n, you're right. Okay. Simplify that, limit as n approaches infinity. Well, this limit right here goes to 1. So that just leaves me with the absolute value of x minus pi is less than 4, meaning the center is pi and the radius is 4. Okay. All right, we have an option now. That's the answer to the problem, right? The radius is 4. We have the option of continuing this problem and trying to check the endpoints. Do you want to check the endpoints?
Yeah. Oh, no. Because it asks for radius.
No? Okay. We won't.
Oh, wait. Do you mean just
wait.
four?
Let's do
Yes.
that. Let's do that.
Let's check the endpoint. Yeah. This is what I'm here for.
That's why I'm asking. Do you want to check the endpoint?
I think we were confused because we were like, do we, like, yeah, whatever. Yes, let's check the
Definitely
endpoint.
check.
Okay.
It's not geometric.
Extending the problem. Let's check the endpoints. The interval of convergence would be the center minus the radius, so pi minus 4. And then pi plus 4. My hand's getting cramped from pushing so hard on this. So what do you want to check first? X minus pi or x plus pi?
That's fine.
Or pi minus 4 or pi plus 4?
Pi plus 1.
Pi, Henry's
I feel
I feel like
we're
we should
going
go left to right. Yeah.
left to right. Okay. Let's try x equals pi minus 4. There's reasons why you'd want to do either one of them, but x equals pi minus 4, then our series becomes, well, our series was n plus 1, n plus 2 over 4 to the n, and then x minus pi to the n power. If we say x is pi minus 4, that's going to give me n plus 1, n plus 2, negative 4 to the n. Okay, so now it works better if I use a light touch on the pen. Okay, and I think we've seen enough of these now where we know that, yeah, that's going to be, well, I got to get past all this stuff, right? N plus 1, n plus 2. But then this is negative 1 to the n, 4 to the n, on top of 4 to the n. The 4 to the n's cancel out.
That's 2. 4 plus 2.
And the series becomes negative 1 to the n, n plus 1, n plus 2. Okay, so that's a lot of simplification. That's probably why this problem, as stated, doesn't actually have you do this. But let's see. This is an alternating series, right? So if you see this is an alternating series, you're just going to go ahead and write alternating series because that signals to the reader that you know what you're looking for. Where'd my cursor go? Oh my gosh. You know, this thing used to work so well. I don't know what happened. Okay, so there's an alternating Oh, that doesn't look at all. That doesn't look at it all. Guys, almost faster if I just type this at this point. This is an alternating series, right? So in our alternating series, we just need to check what is the limit as n approaches infinity. Uh-oh, back to the pen. Oh. The limit as n approaches in... Oh, that doesn't look at it all. I'm so disappointed. The limit as n approaches in... I don't know.
Like it a little bit.
I don't know what to do here, guys. I really don't. I really don't know what to do. The limit... Do you see limit there? Here we go, limit. The limit as n approaches infinity. How do you put an infinity here? Inf t? Of the general term, which was n plus 1, n plus 2, that approaches infinity, right? Oh, jeez. What did I do wrong? It was supposed to say infinity. Infinity. Yeah. So if this series has a limit of that's not 1. Oh my gosh. That means that the series diverges. At x equals pi minus, no, yeah, pi minus 4, which is not equal to 0. Which is not equal to 0. NE not equal to 0. Yeah.
Because it's Leibniz.
Was that?
Leibniz test.
Leibniz test.
So
Yes.
if the series was 0, it would converge.
Yes, but that's the way the Leibniz test works.
Yeah, it's just that.
Okay, so I'm making a mess out of this, so I think I should stop that. Questions on that endpoint? Let's check the other endpoint. What happens when x equal, okay, the other endpoint.
I believe the 4 is going to be positive, right? And it's divergent anyway.
How do you know that?
It's like,
Can't just assume.
Pi
you're right.
plus 4.
You could leave it into
Okay, so at pi plus 4, I'm going to try this again with the pen. At pi plus 4, we get I'm forgetting n.
Yeah.
N plus 1,
plus 2.
n plus 2 over 4 to the n. And then pi plus 4. Just making a mess here. Making a huge mess here. Battery's running low. Pi plus 4 minus 4 to the n. Is that right? No, minus pi to the n. Pi plus 4 minus pi. Okay, so that gives us n. I'm crying here, guys. N plus 1. N plus 1. N plus 2. 4 to the n over 4 to the n, and that's equal to the series n plus 1, n plus 2. Okay. I take a look at that series and I say, well, that limit's never going to be equal to 0, right? So actually, this is the nth term test that we're going to use right now. So the nth term test, which looks a lot like the Leibniz test, by the way. We got the limit as n approaches infinity of n plus 1, n plus 2. That's equal to infinity, which is not equal to 0. So the nth term test tells me that we have divergence there. So we've checked both endpoints, they both diverge. Yeah.
What are the rules for the nth term test?
Nth term test says that if the series, if the limit of the general term goes to anything other than 0, the series diverges.
Okay.
If the general term has a limit that is 0, then we need to do another test.
Oh, so if a 0 doesn't converge, it just
0 doesn't, it never shows convergence, it only shows divergence.
Okay, and then also just another question for FRQs on this or the AP test, do you need to state what test you're using?
It'd be a good idea if you did.
Okay, safe.
Yeah. Mm-hmm.
So
especially if you know what it is.
you could use the integral test with this one.
You could have used the integral test. Yeah.
How come we didn't use the absolute value or the alternating?
Yeah, we could have. If we went to the pi plus 4 first, then we could have shown that the pi minus 4 wasn't converging because of absolute convergence. But what are you going to do? Just a matter of choices, really. This is one of those places where there's more than one way to actually solve the problem. Okay, okay, so that's question 1. That took an awful long time, but that's technology problems too. Let's look at problem 2. We've got the interval of convergence. You know what I'm going to do? I'm going to open the review. And I'm going to copy and paste the problem.
Oh, that's fine.
Yeah. Of course, now I have to wait for Chrome to open. There's Chrome. Question 2.
We should put that question on first. Should be one the FRQ.
Question 2. Right, so now that's taking an awful long time also. What is this? The series, right? Where do you think series would be?
That's right there, large operator.
Large operator? Okay. So this is series... Yeah. N equals 0 to infinity. And we have natural log of x to the n power. Okay. That's a geometric series, right? Geometric series. So this converges when the absolute value of the natural log of x is less than 1. Okay. What are you supposed to find? The interval of convergence? Okay. So in order to do this one, I think it's easier to just say negative 1 is less than the natural log of x is less than 1. Now you're going to exponentiate. So e to the negative 1 is less than x is less than e to the first power. I better do that. E to the first power. Okay. And that's my interval of convergence. You're really kind of done right there. Since this is a geometric series, the endpoints will never converge. Okay. Geometric series are nice like that, right?
They are.
Yeah, all of them should be geometric.
Yes.
Yeah, maybe tomorrow should
Like question 3.
surprise everyone. Only geometric series.
Question 3 is another series.
We do, like you expand the absolute value into like negative 1 and 1 when you can't work, like you can't make
Yeah.
you can't
Yeah.
isolate that, right?
Mm-hmm. Okay, so let's get that series here.
I mean, that one's pretty hard.
All right. So this is in fact another geometric series. So in order to do this one, we're going to have to, again, the absolute value of the ratio. The ratio is x squared minus 4. The whole thing on top of 21. And then this whole thing to the n power. This doesn't look nice either. Absolute value. This needs to be less than 1. Oh, what am I doing? It's just I don't need the power, right?
Yeah, it's just. It is.
Okay, we can multiply both sides by 21, right? So we got the absolute value of x squared minus 4. Absolute value of x squared minus 4. That should be less than 21, right? And then this is one of those weird ones, right?
It is.
It is.
It is indeed.
It is indeed. So we're going to have to, what, negative 21 is less than x squared minus 4 is less than 21. Yeah, we're going to add 4 to both sides.
Yep.
When we add 4 to both sides, what do we got? Negative 17.
Yeah.
Negative 17 is less than x squared is less than 25. Is that right? Okay. And then we're going to note that x squared is always greater than 0. So what we're saying is basically the x squared just needs to be less than 25.
Other than plus or minus.
Yes. Now we take the square root, and the absolute value of x needs to be less than 5.
You moved the 4. It's a coincidence. So it's like, that's like an error.
Huh?
What about the
You
center?
can't move the 4.
You can move the 4.
Yeah, you can't. But like if you do that, can't move the 4. You can't move the 4. Like number 2.
Wait,
You just did.
It doesn't work.
I added 4 to both sides.
No, but not in the absolute value.
Not in the absolute value, no.
Right, but you just like you can't.
You have to take it out of the absolute value before you can add that 4.
Absolute value.
Huh?
You can't move the 4.
Center is going to be 0.
Okay.
It's just like a symbol.
Does all that algebra work for you?
Just
Yeah.
It is kind of weird.
It's weird because if you do it wrong, you get the right answer.
Yeah, that too. So what are we doing here? The interval of convergence, yeah, negative 5 to 5. Okay? Does that all work for everyone?
Yes, it does.
Can we skip over to like 7, 8, and 9? No.
No, I actually want to know the rules for the ones where it's just like 1/6 less than.
How about we do this? We'll do 4, and then we'll do 7, then we'll do 5, and then we'll do 8.
Oh, yeah, that sounds perfect.
Sound fair?
More than
4. Divergence or convergence for this series, which is... Oh, I said I was going to screenshot this, right? So let's screenshot it. Question 4 is this one, right?
Yeah.
This one. Okay. Convergence or divergence. So what's the best way to do this? Well, you have options, right? You could use an integral test, obviously. You can always use an integral test. There is a ratio test. It's very popular. What else can we do? If we think it's going to diverge, we can use an nth term test. Since I have an exponential function in the denominator, I don't think this is going to diverge. We could also use a limit comparison test, but all of those are kind of weird, right? So, yeah.
This is a more general question.
Sure.
But is there ever a time where you have to use the integral test? Like there's no other, like you can't use the ratio test, like there's no other options?
I'm sure there is.
Okay, but like...
I can't think of
I
one.
could, yeah.
In this, as far as like AP calculus goes, we don't actually use the integral test all that much.
Right, that's what I felt like when I got there.
It's just take cool.
Okay, so let's use the ratio test then. Ratio test. We're going to take a limit. See, why isn't limit as n approaches infinity? Why is not one of the common ones? It's way more common than this one.
What is that?
That's e. Is there more hidden that I don't even know about? No. Can I customize this? I don't know. Let's not take the time to find out. N is going to approach infinity. I already learned how to do infinity. Infty, yeah. Not that I couldn't write the word infinity just as easily. Alright, so we have to do n plus 1, right? So numerator, n plus 1 to the third power plus 8. Close the numerator. The denominator is going to be 6 to the n plus 1. Ooh, nice.
That looks good.
Where's the dot operator? Do you think there's a dot operator here somewhere?
Oh, it's wrong. It makes me.
Do you see the dot operator? Here we go. No, wrong operators. These are not the operators you're looking for. You see a dot anywhere?
Is it right next to that?
Alright, why don't we just use it?
Let's go to special characters.
Do you see the multiplication x?
No.
I just put that dot. Why are there Hebrew letters up there?
Right next to
Oh,
it.
we
No
good.
Hebrew letters.
Oh,
Yeah, they are.
okay.
Right there.
Really good.
Oh, that's the back.
All in red.
Times, let's see, 6 to the n divided by n cubed. No, yeah, n cubed plus 1 plus 8. Sweet. Okay. All right. I'm going to take this and I'm going to copy and paste it.
Yeah, that looks good.
That does not look awesome. That still doesn't look good.
How about this?
Okay. Let's simplify that then.
Let's.
Got a limit as n approaches infinity. N approaches infinity. Okay, that numerator here, that's going to simplify to, what is that, n cubed plus 3n squared plus 3n plus 9.
I mean, do we have to know how to do that?
Don't you know how to do it?
I mean, I could do it with like the two polynomials and then multiply it again. But I don't know how to
Just use Pascal's triangle.
Pascal triangle.
I do that like 4 years ago. I just draw the triangle.
Varia. I did not do it this way, but I got this one.
Yeah, well, I mean, because you
All
get
you
to
need to know
know
is that the first term goes to the third power.
Yeah.
Yeah.
All you need to know is that the first term goes
Yeah,
to
all
the
you
third
have to
power.
do is use it. That's
But I guess if it's less
Okay, well, listen, you know, I'm just gonna do it my way.
I'm trying to.
Yeah, this is true. The only thing that really matters is the first term. And I guess I'm showing off. I don't know.
Yeah.
I am. That's funny. N cubed plus 8.
cute.
Is there extra cut out?
Don't remember. I still have to photocopy it.
Oh, dude.
Okay, so we have that. The 6 to the ends and those all cancel except for the 6's, right?
Yep.
Okay, so what do we have then? Same limit. N's going to approach infinity again.
50.
What's this going to be then? It's going to be n cubed plus stuff. Okay, I really shouldn't do that, should I?
That's nice.
3n squared plus 3n plus 9 divided by 6n cubed plus, what's 6 times 8? 48? What the hell just happened here?
I mean, yeah.
I didn't do this.
Well, I mean,
I'm
no.
totally different, and I thought we did it together, so.
No, I mean, I didn't do it this way, but the idea is still the same. It's n cubed, and cubed cancels, gives you 1. Like, just
Yeah.
showing all the steps.
Is that okay? I mean, I don't know. You tell me.
You could also just go n plus 1 over n cubed,
Mhm.
and then it goes to 1.
Yeah, that works too.
Okay, cool.
But I mean, the main thing here is that we have this limit's going to be 1/6.
Basically.
Yeah.
Yeah, are we agreed here? This limit's 1/6
Yes.
Yeah. So I
equals 1/6, which is less than 1. So the series converges.
Is it just like a rule?
Hmm?
That that's the rule. If it was 2, for example, then it would diverge, right?
Yes.
So if it,
The ratio test is ratio test.
Oh right, I remember. If it's less than
If the
1.
limit is less than 1, you get convergence.
Yeah.
If the limit is greater than 1, you get diverges.
And if it's 1, then it's inconclusive.
Limit equals 1, inconclusive. Converges.
Mr. Ferry, if we get inconclusive on the test, I'm gonna start crying.
Oh.
That's what
I'll know what it is.
Yeah.
Well, that's what happens
If I
if
can
you
do
do
it,
that
that's
you
Is that?
I don't know.
What do we do after we take the integral test? Come on.
You have to do a different test.
That's what I said, right?
Yes.
Yeah.
If it's inconclusive, then you may want to think about the integral test.
Oh. Actually, sorry.
How does the dropout happen?
I feel like this multiple choice question isn't worth it.
The integral test is if you get infinity divergence, you get like anything else besides infinity.
One more time.
For the integral test, if you get infinity diverges, anything else inconcussive, right? Yeah.
Okay, 7. I said we were going to do this.
Try your hardest. If you fail, that's
It'll drop if we fail. Or not drop, but replace with.
Here is our number 7.
No, I don't like
That one is great. I did this all by myself, and then I saw your work, and it was correct, and I was like, oh my god.
I'm going to try this pen again because I'm super frustrated.
Well, we just get 7.
If you
Yeah,
It's gonna go back.
I'm going to go, yeah.
But I mean, number 5 is the same as number 4.
All right, so 7 we have, this is a words escaping me, power series now, right? So we're going to do the limit as n,
I vote the whiteboards.
what kind of battery is this?
I don't think we do it.
It's a AAA Energizer lithium battery, and
Oh, I
it's
have one.
still not working. Yeah. Was that? I don't know what I want to do. I want to throw this out the window.
Oh,
No, it doesn't look like it's working all that right. I don't know. Let's see. Take the limit as n approach. Oh, it's working.
just take the battery out, put it back in.
Interesting. X minus 9
I think there's gray in the stuff.
to the n plus 1 divided by 6 plus 2n plus 1 multiplied by 6 plus 2n over x minus 9 to the n power. We want absolute values, and we want to make sure this is less than 1 so that we get an interval when this converges. Okay, and stop yo-yoing me around. Okay, limit as n approaches infinity. Let's simplify that. I get x minus 9 on the numerator. That simplifies just fine, over 1. And then I have 6 plus 2n on top of 8 plus 2n, less than 1. Clearly that x minus 9 gets to escape. And then you have 6 plus 2n over 8 plus 2n. This limit goes to 1. So the absolute value of x minus 9 is less than 1. The interval, the open interval, that doesn't look good. The open interval is x between, let's see, 9 minus 1 is 8, 9 plus 1 is 10. So we need to check 8 and 10. Every time we use a ratio test, we have to test the endpoints. Is my clock off by an hour?
It's 4:23.
I can't recall.
What was the time change?
Oh, the time change.
Yeah. You haven't noticed?
No, I only look at the hour hand, or the minute hand, really.
It's so much darker than that. You don't like, yeah, it doesn't affect your sleeping patterns. How?
No, I don't use that clock. I don't have that clock at home, so I don't know how that affects sleeping patterns.
Oh, because you
I'm
know that's
not ever going to do physics ever again. After how many
Okay, when x equals 8, we get
Ow.
because like
I use my
8 minus 9 to the n
This
over
is why I'm here, guys.
6 plus 2n, which is the series negative 1 to the n on top of 6 plus 2n. This is an alternating series, so I'm going to write alternating series so that the person reading my paper thinks I'm smart. Whoever's going to be reading your paper on the AP test won't know how much of an idiot you are. You know, because they don't have to see you every day. They only have to look at your work. So.
And they don't even know whose work it is.
So this is an alternating series. Let's take the limit as n approaches infinity of the absolute value of the term, which is 1 over 6 plus 2n. Let's figure out what that limit is. Oh, that limit is 0. So we have converging. Converges. Someone remind me the next time the pen freaks out to take the battery out and put the battery back in, okay?
Is that like?
That's the Leibniz test, yes.
Yeah.
Can you put alternating series test? Is that okay?
bracket.
Are you at put Leibniz test?
Okay, yeah, so this means we're going to bracket at 8. Okay. Let's check at x equals 10. Is it 10, right?
Yeah, it's
Yeah.
done.
Yeah.
Check x equals 10. We get absolute value of 10 minus 9 to the n power over 6 plus 2n. Is that right? Okay. And that simplifies to 1 over 6 plus 2n. That is not a p-series, but it's almost a p-series. So we're going to LCT this. The nth term test here would be inconclusive.
Why are they 0?
Nth term test, the limit would be 0. Nth term test is inconclusive. So the LCT with the series 1 over n, because that's the closest p-series.
So the procedure for that would be to take the highest exponent in both the numerator and denominator, and then simplify it, and then whatever you get, and then 1, obviously.
Yeah. Okay, so let's compare this. We need the limit as n approaches infinity of 1 over 6 plus 2n on top of 1 over n. And that's going to be equal to the limit as n approaches infinity of n on top of 6 plus 2n. Now, I expect that you can look at that limit and know that it's 1/2. Is that fair?
Oh yes.
Okay. After all the limits we've done, that's 1/2. Okay. So LCT says since this series 1 over n diverges, then this series 1 over 6 plus 2n also diverges.
So if you get a negative number, you can't use this test, right?
It should always be a positive number.
Okay. So basically, that's just to show what
Yeah.
you usually can use
So the results for LCT.
Hmm?
You see the results for LCT.
What if it was like n over 6 plus 2n squared, for example? Would it be like the closest p series be 1 over n squared?
Ooh, yeah, 1 over n squared.
And what would the limit? The limit would be 1 over 2n, right? So that's like that.
1 over 2. Wait, hold on. We're saying
If it's 2n squared instead of 2n.
1 over 2n squared.
Yeah. It turned out to, yeah. N
Well,
over-
why don't we do 6 plus 2n squared? If we did that,
Yeah. And
the closest p series,
1 over n squared.
1 over n squared.
That there.
Oh, it still becomes n. Oh, yeah. It's still divided. You have to do the. Yeah. Okay.
It's still gonna be 1/2
Yeah.
since this
Said
converges.
something and responded. That wasn't my opener.
This one also converges.
Okay.
She said, "How can you see it?"
Okay, so should we summarize that LCT test then?
Yeah.
Is that fair? Do you see my okay? So LCT, compare two series. Compare the limit of two series. Okay. If the limit is a number, any number, both series
Oh, I see. So you
Will-
get infinity. That's
will either converge or diverge. Okay. If one series converges, the other series also converges. If one series diverges, the other series diverges.
Also, for this is like just given that series of 1 over n diverges.
Yes, that should be memorized.
Yeah, that's what I thought. And like for 1 over n squared.
That converges because it's the p series and p is greater than 1.
Oh yeah.
Wait,
Okay, got it.
do you have to compare it to a P series?
It's easiest to compare to a p series, but you can compare it to whatever series you like.
Alright.
Okay, so that was number 7. I think we said we are going to go back to 5.
Thank you, Mr. Farabee. Yeah, because 8 and 9 because I was supposed to take it today, so I should be prepared.
It's kind of weird though. Like the answer for it.
Let's check 5 now. 5, convergence and divergence of this series n cubed over 3n, 3 to the n power. Uh-oh. Right. What number is this?
Oh yeah, I saw
5.
that.
Does that look like a 5 yet? Okay.
Yeah, it's
5 we have... Uh-oh. Okay, hold on. Take out the battery. Swish it around a little bit. Put it back in. And Viola. N cubed. Why does that work?
you just get the electricity going.
3 to the n. Okay. So what do we think?
Shake it.
We can use any of the series that we know. We could use obviously the ratio test. We could use the integral test. If this looks like it's going to diverge, we could use the nth term test. We can compare it to a p series if that's going to help. But based on the fact that we have two different function types here, I think the ratio test is probably the best one to use. Okay. Ratio test. It really is one of the, I call it one of the big guns in the arsenal. Okay. So we got n plus 1 cubed over 3 to the n plus 1 multiplied by 3 to the n on top of n cubed.
But the ratio test only shows it converges. It doesn't show like where it converges.
It doesn't show what it converges to.
Yeah.
It only shows that it does converge.
Okay.
Okay, so let's simplify that. We have 1/3 is going to come out. Uh-oh. Time to swish around the battery again.
Shake it. They need to shake it.
You should
Why
probably.
don't you take it out?
We should do it.
There's probably something
You think it's a gunk problem?
Yeah.
Maybe it's dying.
That's what we learned.
Doesn't work shaking.
I'm shaking.
Don't
They use like rubber really hard.
All right, so we got 1/3 coming out of that. We've got
your
The-
method is
The limit as n approaches infinity. Oh, please keep working. What is that? N cubed plus 3n plus 3n plus 1. That's me showing off again, is that right?
yeah.
Over n cubed.
So it's 1.
So this series, or this limit here is 1. We've got the 1/3 on the outside, so this is equal to 1/3, which is less than 1. So convergence.
Can we do 15?
Right, let me just do this gunk theory first.
Yeah, wait a minute. Thank you for
Yeah, have a good day.
Can you find what they converge to?
Find which convergence.
Like this type of series?
No.
Yeah, no. You can't find He won't ask us.
No, it won't be. It won't ever be a question unless it's a geometric series or one of the series that you have memorized. It's the only time it's going to be asked. Okay, so what are we going to next? Number 8.
Yeah.
8. We have x minus 3 to the n over 3n factorial. Ooh. Okay, let's do the same thing. We're going to do a ratio test. Because it's a power series, ratio test works really well for power series. So the limit as n approaches infinity, let's do this. X minus 3 to the n plus 1 on top of, now be really careful here because it's 3n plus 1 factorial. Okay, be really careful about the way you substitute that. Multiply that with 3n factorial x minus 3 to the n power. Force that less than 1. That all work? Good. By now we should know that the x minus 3 is going to pop out of that limit. Okay. On the numerator I'm going to have 3n factorial. On the denominator I'm going to have 3n plus 3 factorial. Okay, which of those two is bigger? 3n factorial or 3n plus 3 factorial? 3n plus 3 factorial. Good. So that's the one that we're going to simplify. 3n plus 3. So we're going to do x minus 3, the limit as n approaches infinity of, okay, that's still 3n factorial up there. But we're going to start with 3n plus 3. What's the integer before 3n plus 3? It's 3n plus 2. What's the integer before 3n plus 2? 3n plus 1. What's the integer before 3n plus 1? 3n. And now that I have a numerator and denominator that matches, I'm going to stop and give it the factorial. We want this to be less than 1. Okay, it looks to me that we can cancel that with that, giving me the absolute value of x minus 3 multiplied by the limit as n approaches infinity of 1 over 3n plus 3, 3n plus 2, 3n plus 1. What is this limit? That's 0. So basically we get x minus 3 multiplied by 0 is less than 1. Okay, so is there a value, no matter what you put in for x, your limit's going to be 0, right? This is all, no matter what x is, this ratio is going to be less, no matter what x is, this ratio will be less than 1. That's why the interval of convergence is x is all real numbers. Because it doesn't matter what number we put in there, this series will converge. The ratio test will give me 0, so the series is going to be converging. Yeah, David? Okay.
It's because of the 0, right?
It's because of the 0.
Can you, since 9 is the geometric series, can you just denote 15?
The limit and
That's 7.
Well, we have 6 and 9. Did you want to look at 6 also?
Yeah, we'll just more or less do it.
Okay, so let's look at 6 then, and then we'll look at 15. 6. Okay, so we have limit comparison test. We've got 4n over n squared plus 3. Okay, so we got to find a p-series that's closest to that. And I'm going to look at the lead terms only. Lead term of the numerator, lead term of the denominator. That's going to be 4n over n squared. That can simplify to 4 over n, and which we're going to simplify further to 1 over n.
It doesn't have to be like bigger or smaller. It just has to be something that's comparable, right?
Yes. Okay, so LCT says we're going to take the limit as n approaches infinity of, well, let's put this one on the numerator. 4n on top of n squared plus 3. And let's put this one on the denominator, 1 over n. In reality, it doesn't matter which one you put in the numerator, which one you put in the denominator. We're just going to do it like this. Okay, so this is equal to the limit as n approaches infinity of 4n squared on top of n squared plus 3. This limit is 4. So since this series diverges, this series is also going to diverge. Looking good?
How do you know divergence?
Which series? This series? That's the harmonic series. That's known to diverge.
Okay.
It's our special case.
Even if it was like 1 over n cubed, it's
1 over n cubed is different. That converges.
P series. So if it's a 1 over n to the p, if p is less than 1,
What were your pieces?
diverges.
Nash?
Oh, I don't understand why you would use 1 over n, and why would you use 4n over n squared?
We start off with 4n over n squared because those are the lead terms of the numerator and denominator. Once we've simplified the lead terms to 4n over n, and then any constant that's left over, we turned it into a 1. And that'll get me the closest p-series.
So like, if they don't, so like it was an n like next to the number, so it makes it useless. Like you have to just like.
No, we're looking for the lead term, the highest ordered term. So the numerator only has 1 term, so its lead term is 4n. The denominator has 2 terms, n squared and 3. The one that has the highest power of n is n squared. So you're only using the highest powered term.
Thank you. Thank you.
Okay, so 15, yeah?
Yeah.
15.
So we're going to say 15?
Yeah, we're going to...
We looked at it like 2 days ago, so. 2 days ago?
Yeah, I don't mind 15. Okay, so let me just read through this, make sure I got this. We've got this series, n goes from 1 to infinity, of x to the n to the n, man, I don't like that n to the n, over n factorial. And we want to know when does this for all x when this series converges. This is equal to f of x. So the first thing we're supposed to do is find the radius of convergence. Given the fact that we have a bunch of different kinds of function pieces, we're going to use a ratio test. So let's use a ratio test. That means we take the limit as n approaches infinity, absolute value, x to the n plus 1, n plus 1 to the n plus 1, over n plus 1 factorial, multiplied by n factorial, x to the n, n to the n. And we want that to be less than 1. Okay, let's simplify that slowly. This is the limit as n approaches infinity. That's x to the n power multiplied by x. That's n plus 1 to the n power multiplied by n plus 1. The denominator is n plus 1 multiplied by n factorial. I'm stopping at n factorial because I know there's already an n factorial in the numerator. We've got n factorial in the numerator, what we were just talking about. We've got x to the n in the denominator, and we've got n to the n on the denominator. And we want to show that that's less than 1.
The top one is factorial, not n.
Yeah, that's factorial, you're right. Okay, so from here we're going to cancel things out. X to the n cancels out. N factorial cancels out. What else cancels out? Oh, n plus 1 cancels out with n plus 1. Is there anything else? I think that's it, right?
You're good.
Yeah. We're good. Okay. So, the absolute value, no, we said we're going to do this slow. The limit as n approaches infinity. That numerator, I have an x and an n plus 1 to the n. That denominator, I have an n plus n to the n power. That means I get the absolute value of x, the limit as n approaches infinity of, well, just to do a little simplification, that's n plus 1 over n, the entire thing to the n power.
Thank you.
Okay, so what we're going to do now is we're going to deal with that limit, because that is not a nice limit. It's actually kind of the opposite of nice.
Was this like 1 over infinity, 1 to the infinite power?
Kind of. So we can simplify that to n over n plus 1 over n, the whole thing to the n power. This is going to be a side problem. Okay, so the limit as n approaches infinity of 1 plus 1 over n to the n power.
Oh, but yeah. What do you want
Wait
to
a sec.
Mhm.
The side problem, you just split the terms up, right?
No, I mean this.
If you just working with the limit.
Yeah, I need to find that limit before I can continue the ratio test.
Okay.
So we're stopping the ratio test. We're trying to compute this limit first. Okay, so since we have something to the n power, we're going to use that y equals 1 plus 1 over n to the n power.
Isn't that what you were just talking about? Like one of the...
It is, actually. It's exactly what we were talking about. We're going to take the natural log. That's going to be n multiplied by the natural log of 1 plus 1 over n. And then now we're going to take our limit as n approaches infinity. We know when we do this, we get an infinity multiplied by, oh, I forgot the natural log, didn't I? When I do this, as n goes to infinity, obviously this n goes to infinity, but this n, when this n goes to infinity, we get 0, and then the natural log of 1 is 0. So infinity multiplied by 0 is one of those indeterminate things. So we're going to try to use L'Hopital's rule to figure out that limit. So we'll do the limit as n approaches infinity of the natural log of y. That's equal to the limit as n approaches infinity. My numerator is going to be the natural log. My denominator is 1 over n. So now I have 0 on top of 0, and I can use L'Hopital's rule. Limit as n approaches infinity of the natural log of y is equal to, now the derivative of the natural log is 1 over the thing multiplied by the derivative of the thing. It's negative 1 over n squared. The derivative of 1 over n is negative 1 over n squared. Those 1 over n squares cancel. Yeah, and what's left over that's going to be equal to the limit as n approaches infinity, 1 over 1 plus 1 over n. N goes to infinity, that becomes 1 over 1 plus 0, which is just 1. Why did you do that to me? So when we exponentiate, the limit as n approaches infinity of y is going to be e to the 1. Or to put it in another way, the limit as n approaches infinity of 1 plus 1 over n to the n power is equal to e. So this is how the ratio tests can be difficult, is if you have a difficult limit inside the ratio test.
Can you memorize this, or do you have to?
You can absolutely memorize this.
Awesome. Memorize what? 1 plus 1 over n plus n.
Lots of people memorize this. Back to the ratio test.
So it's absolute value of x times e is less than 1.
Yeah. So the absolute value of x multiplied by, and we're going to put e there now, is less than 1. So the absolute value of x needs to be less than 1 over e. Radius of convergence, or center of convergence, is x equals 0. The radius is 1 over e. That's part A. That's a hell of a problem.
Do we do endpoint test?
Huh? Oh, we got to test the endpoints. You're right. No, well, it's just as the radius of convergence, right?
So it doesn't ask for
It doesn't ask. Since this is such a hell of a problem, we're not going to try to extend this. Yeah. Part B. Use the first three terms to approximate f of negative 1/3. Okay. What are the first three terms? F of x can be approximated by, when n equals 1, we get x. When n equals 2, we get 2 squared, which is 4,
2x.
over 2, so 2x squared. Is that right? 2x squared? When n equals 3, we get 3 cubed is 27. 27 over 6 is 9 over 2, so 9 halves x cubed. Is that right? N to the n, so 3 to the third power is 27. 3 factorial is 6. So 27 over 6, 9 over 2. Yeah, 9 over 2. Okay. F of negative 1/3 then? Can be approximated by negative 1/3 plus 2 times 1/9 plus 9 halves of negative 1 over 27. Yeah, Mash?
But since it's alternating now, would you want us to go back and like add an extra one for the next part?
Well, let's see. Yes, this is an alternating series. So we can do that. Can I leave this answer the way it is?
Yeah.
Are there any fractions in a fraction? No. All multiplication and addition? So we're good.
Oh, I solved it.
What'd you get?
Negative 5/18.
Negative 5/18.
You can leave it as that.
You can leave it, yeah, you don't have to. In fact, I'm just going to leave it like that. Okay. All right, so this is an alternating series. Let's do part C. So that means the error is going to be less than the absolute value of the very next term. The very next term happens when n equals 4. So that's negative 1/3 to the 4th power. That is 4 to the 4th power on top of 4 factorial.
So, do you go by terms or the power?
For error,
Yeah.
power.
Always power.
Yes.
Okay, got it.
Okay, I don't think you need to simplify that. That looks pretty good to me. There's no fraction inside of a fraction. 4 to the 4th power, I'm never going to ask you to know what that is. 4, 2, is it 256? 16 times 16?
It's 240 plus 16. Yeah.
So that's pretty good. If you want to simplify that, that's your business. Just don't do it wrong. That's it. Justification is this is an alternating series. Okay?
That's it for the
That's it. Alternating series error is always smaller than the first unused term.
Thank you.
Back down.
And that's it. Did that say 5 o'clock?
Yes.
All right. Have a good one.